Ashe. My dear friends, I am your royal narrator, Queen Magical Melanin, extending a warm greeting to all gathered for our basic applied electronics information session produced by our esteemed elder Baba Jelani Bamani Dembe, the brilliant mind behind Majestic Mind Matters University and the mandatory Mental Liberation series, eagerly enriching our learning journey. Today, we venture into the world of basic applied electronics, where circuits and currents intertwine to unlock endless possibilities. Let us embark on this enlightening adventure together, exploring the wonders of technology and innovation under the guidance of our distinguished elder Baba Jelani Bamani Dembe. Welcome to a transformative experience that will ignite your curiosity and mastery in the field of applied electronics. So pay close attention and take plenty of notes to prepare you for possibly answering a few easy questions near the end of the session. In this basic applied electronic information session, you will be introduced to the Dual Inline Package, DIP. Dual Inline Package, DIP, is a type of packaging used for integrated circuits, ICs, that consists of two parallel rows of pins extending from the sides of the package. This type of packaging is commonly used in electronic devices, such as computers, mobile phones, and other electronic gadgets. Applied electronics technicians need to have a thorough understanding of DIP packaging in order to properly install, troubleshoot, and repair electronic devices. One of the key things that applied electronics technicians need to know about DIP packaging is how to identify the pinout of the package. Each pin on a DIP package is numbered, and technicians need to be able to identify which pin corresponds to which function on the IC. This information is typically provided in the datasheet for the IC, which technicians should have on hand when working with DIP packages. By understanding the pinout of the package, technicians can properly connect the IC to the rest of the circuit and ensure that it functions correctly. Another important aspect of DIP packaging that technicians need to be familiar with is how to properly handle and install the package. DIP packages are typically inserted into a socket on a circuit board, and technicians need to ensure that the pins are aligned properly and that no pins are bent or damaged during installation. Improper installation can lead to connection issues and can potentially damage the IC, so it is crucial for technicians to be careful when working with DIP packages. In addition to installation, applied electronics technicians also need to know how to troubleshoot and repair issues with DIP packages. If a device is not functioning correctly, technicians may need to check the connections between the DIP package and the rest of the circuit to ensure that there are no loose connections or damaged pins. They may also need to use a multimeter to test the functionality of the IC itself and determine if it needs to be replaced. One of the advantages of DIP packaging is that it is relatively easy to replace a faulty IC, as the package can be easily removed from the socket and replaced with a new one. However, technicians need to be careful when handling DIP packages, as static electricity and physical damage can cause the IC to fail. By following proper handling procedures and taking precautions to prevent static discharge, technicians can minimize the risk of damaging the IC during replacement. Applied electronics technicians also need to be aware of the different types of DIP packages available and how to identify them. DIP packages come in various sizes and configurations, including dual inline, quad flat, and zigzag packages. Each type of package has its own unique pin configuration and size, so technicians need to be able to identify which type of package is being used in a particular device and understand how to work with it accordingly. Applied electronics technicians need to have a thorough understanding of DIP packaging in order to properly install, troubleshoot, and repair electronic devices. By knowing how to identify the pinout of the package, handle and install the package correctly, troubleshoot and repair issues, and identify different types of DIP packages, technicians can ensure that electronic devices function correctly and are repaired efficiently. DIP packaging is a fundamental component of modern electronic devices, and technicians must be familiar with its intricacies in order to be successful in their field. Applied electronics technicians play a crucial role in the field of electronics by ensuring that devices and systems function efficiently and effectively. One important aspect of their work is understanding the various components and packages used in electronic devices. Dual Inline Package, DIP is a common type of package used in electronics, and technicians need to have a thorough knowledge of its applications in order to troubleshoot and repair electronic devices. In this essay, we will explore some common applications of DIP in electronics and discuss what technicians need to know about them. Integrated circuits, ICs, are one of the most prevalent uses of DIP packages in electronics. ICs are essential components in electronic devices, providing various functions such as processing, control, and memory storage. DIP packages are commonly used to house and connect ICs in devices such as computers, consumer electronics, and industrial equipment. Technicians need to be familiar with the pin configuration and layout of DIP packages in order to properly install and replace ICs in devices. Memory modules, such as RAM and ROM chips, also use DIP packages for housing and connecting the memory components. These modules are essential for storing data and instructions in electronic devices, and technicians need to understand how to troubleshoot and replace faulty memory modules in devices. Knowing how to handle DIP packages and components is crucial for ensuring that memory modules function properly in electronic devices. Microcontrollers are another common application of DIP packages in electronics. Microcontrollers are integrated circuits that contain a central processing unit, CPU, memory, and input/output peripherals. DIP packages provide a compact and efficient way to integrate microcontrollers into electronic systems, allowing for control and automation functions. Technicians need to be proficient in working with DIP packages to install, program, and troubleshoot microcontrollers in various electronic systems. Analog and digital converters, such as ADCs and DACs, are frequently housed in DIP packages in electronics. These converters are used in signal processing and communication systems to convert analog signals to digital and vice versa. Technicians need to be knowledgeable about the specifications and characteristics of DIP packages used for converters in order to ensure accurate signal conversion and transmission in electronic systems. Operational amplifiers are another application of DIP packages in electronics. Operational amplifiers are used in electronic circuits for amplification and signal conditioning functions. DIP packages provide a convenient form factor for housing operational amplifiers in circuits, allowing for efficient signal processing. Technicians need to have a solid understanding of how operational amplifiers are integrated into circuits using DIP packages to troubleshoot and repair electronic devices effectively. Interface modules, sensor modules, power supply modules, communication modules, and test and measurement equipment are other common applications of DIP packages in electronics. These modules play crucial roles in providing connectivity, measurement, power regulation, and communication functions in electronic devices. Technicians need to be well-versed in the various applications and specifications of DIP packages used for these modules in order to maintain and repair electronic devices effectively. Applied electronics technicians need to have in-depth knowledge of the common applications of DIP packages in electronics in order to carry out their work effectively. By understanding how DIP packages are used in integrated circuits, memory modules, microcontrollers, converters, amplifiers, interface modules, sensor modules, power supply modules, communication modules, and test and measurement equipment, technicians can troubleshoot and repair electronic devices with confidence. Mastering the intricacies of DIP packages will enable technicians to contribute to the smooth operation of electronic systems and devices in various industries. As an applied electronics technician, it is crucial to have a thorough understanding of DIP packages and their importance in electronic systems. DIP packages play a key role in integrating control functions within electronic systems, and technicians must be familiar with their characteristics, applications, and working principles to effectively troubleshoot and repair electronic devices. One of the primary features of DIP packages is their two parallel rows of pins that extend from the sides of the package. These pins serve as the interface between the IC housed in the package and the PCB on which it is mounted. By soldering the pins of the DIP package to the corresponding pads on the PCB, technicians can ensure secure electrical connections between the IC and the rest of the system. Furthermore, DIP packages are commonly used for housing various types of ICs, including microcontrollers, microprocessors, and programmable logic devices. These ICs contain the control functions necessary for managing different aspects of the electronic system, such as data processing, communication, and signal processing. By utilizing DIP packages, technicians can easily integrate these control functions into the system, allowing for efficient operation and enhanced functionality. In addition to their versatility, DIP packages are available in different sizes and configurations to accommodate a wide range of control functions in electronic systems. DIP packages can have varying numbers of pins, ranging from a few dozen to several hundred, depending on the complexity of the IC housed within. This flexibility allows technicians to choose the most suitable DIP package for a specific application, ensuring optimal performance and reliability. Moreover, DIP packages are cost-effective and easy to work with, making them a popular choice for integrating control functions in electronic systems. Compared to other types of component packages, such as surface mount devices, SMDs, or ball grid arrays, BGAs, DIP packages are relatively inexpensive and readily available, making them an economical option for electronic design and manufacturing. Additionally, DIP packages are easier to handle and solder compared to SMDs and BGAs, making them accessible to technicians with varying levels of experience. To effectively work with DIP packages, technicians must be proficient in soldering techniques and understand the importance of proper handling and assembly practices. Proper soldering is essential to ensure reliable electrical connections between the IC and the PCB, preventing issues such as intermittent connections, short circuits, and component damage. Additionally, technicians must be meticulous in their handling of DIP packages to avoid bending or damaging the pins, which can lead to connectivity issues and system malfunctions. In conclusion, DIP packages are a critical component in electronic systems for the integration of control functions. Applied electronics technicians must have a comprehensive understanding of DIP packages and their applications to effectively design, troubleshoot, and repair electronic devices. By leveraging the features and benefits of DIP packages, technicians can ensure the seamless integration of control functions within electronic systems, enabling optimal performance and reliability. Thanks for your participation in this special Majestic Mind Matters University Basic Applied Electronics Information session. I am your royal narrator, Queen Magical Melanin. Here is a special message from our esteemed elder Baba Jelani Bamani Dembe, the brilliant mind behind Majestic Mind Matters University. To all applied electronic technicians, he wants you to know this. Your participation with Majestic Mind Matters University has been invaluable. Your expertise and commitment to excellence has elevated our research and knowledge in the field of applied electronics. Thank you for choosing Majestic Mind Matters University as a trusted source for your valuable applied electronics information to aid to your success with this basic applied electronics information session titled Introduction to the Dual Inline Package, DIP. Stay woke. Ashe.